Hey guys, welcome back to another episode. And I am so excited because we received news, during this time that we have physical school being placed on the back burner, and I know a lot of you guys were getting worried that the time frame for revision was just too short. So for a lot of you guys, this is the time where you just got a short break, possibly. We're not sure if exams are going to get pushed back. However, you have the opportunity where you have that time to spend on extra revision. So, and we also received the breakdown of topics, matrices being one of them. So, we are almost done with respect to covering all the past papers that are involved based on the topics that they have given us that are coming. And I wanted to do matrices today, and I think I have one more. So let's get into it. All right, so first up, before we begin my tutorial, I have, I think, at least 11 sessions, 11 videos on matrices uploaded. That's where I actually teach the topic, right? So if anywhere during this video where you are seeing questions being done and you are lost, please be sure to go back to those videos. It will be found within the relevant playlists. And yeah, just give them a review and then get back to the questions. So first up, a lot of people name the locations of their array differently. So I just wanted to write down the way I name my letters within my array. So I call this usually A11. Then I continue A12, A13. All right. And then here, 21, 22, 23. And then finally, 31, 32, and 33. And why do I name my individual elements like as follows? Remember, letters are arbitrary, so it does not have to be common A. You can have B, C, D, any letter pretty much. But you see my 11, 12, 13, to me it has meaning because it's essentially the location of that element in its row by its column. So take, for example, A22. It's located in row number 2, and it's also located in column number 2, hence that little subscript 22. If you were to observe, let's clean this up here a bit. If you were to observe this one here, it's found in, so it's always row by column. That's how you name a matrix. The row this is found in is 3, and it's in the first column, right? So now this is not a 3 by 1 matrix, but using that same format of the way you name a matrix, you can actually identify the location of an element within an array of numbers. All right, so hence the reason why I have subscript A31 or A31 there. So in exams, you can use that little tip to section off your elements in your array. And I will be using this for all of my questions if you come across me using it. Okay, so let's get into it, shall we? So this question, they said that A and B are two matrices given as follows. And part 1, I think this is an easy format question. Part 1, determine the value of x for which A inverse does not exist. Now, if you go back to your basic rules, an inverse tends to not exist when its determinant is equal to 0, right? And when the determinant of something is equal to 0, right, it's said to be singular for those of you guys who did not know that, right? Any square matrix, any n by n matrix, 2 by 2, 3 by 3, 4 by 4, etc. Once it's square, right, it's said to be singular, meaning that its determinant is equal to 0. And if its determinant is equal to 0, based on obviously, the formulas you have for finding the inverse of a matrix, then following up with that, it would mean that A inverse would not exist if the determinant is equal to 0. Okay, so let me just erase this information to the right here. You don't need to write all those statements. You can simply say if A inverse does not exist, right? It follows that the determinant must be equal to 0. So all the information you need to know for this question is how do you find the determinant of a 3 by 3 matrix? All right, take note that this can also be written as determinant of A. All right, guys, anyhow you want to call it. So let's get into it. For a 3 by 3 matrix, the determinant is given as follows. All right, so we set up our determinant here. You can use any notation you like. And you're going to start from that first term. All right, that first value, sorry. And our first value is given by 2. All right, and then you're going to eliminate the rows and columns that belongs to. And you're going to write down the remnants inside here. So 0, 2, 1, 0. So I'm going to 0, 2, 1, 0. All right, so 0, 2, 1, 0. Okay, and there we go. And the trick is just to remember that you will be alternating your signs. So it's positive, then negative, then positive. All right, so we're going to alternate the sign now to minus. And then our next term, I keep saying term, our next, I'm so addicted to algebra. Our next number in the array, letter rather, is given by x. So we will simply write down that value here and follow it up with the determinant of what elements are left after you eliminate the row and column that number belongs to. So if we eliminate, we will have 3, 2. So that's 3, 2, and 2, 0. And then finally, we follow up with a plus sign. And then we have minus 1. And if we eliminate the row and column that minus 1 belongs to, we'll get 3, 0, 2, 1. 3, 0, 2, 1, just for you guys to see, minus 1 belonged here. So if we eliminate that, we end up with this over here. All right. So if you need to see a more detailed analysis of how to find the determinant of a 3 by 3 matrix, be sure to hit up the video that I did on that. So we are just going to get straight into it here. The determinant of this 2 by 2 matrix would be found by multiplying AD minus BC, A, well, if you learned it like that, this by this, that's 0 minus this by this, right? That's 2 minus x, then we have 3 by 0 is 0 minus 2 by 2, which is 4. And then we have plus minus 1 gives us minus 1. And finally, we have 3 by 1 gives us 3 minus 0. Okay, and I'll just work this out in my calculator to get the following on screen. All right, and last thing we need to do is just recall that, of course, for this question, we're going with the notion if A inverse does not exist, it simply means that determinant is 0. So we're going to equate that to 0, and we have formed a simple algebraic equation which we can solve. Right, so minus 4, minus 3, that's minus 7. So 7 on this side, and we have 4x on our right, which implies that x simply equal to 7 over 4. Now, to be honest, I hate when things like this happen because, I mean, all of those numbers were whole, and I would have felt like, yeah, my answer is drop dead correct if I got a whole number. But, you know, such is life. We had to get 7 over 4. You guys can, of course, do a quick workout on your own, and you can leave comments down below if I made a mistake somewhere. But yeah, this is the answer. So this is what is going to happen in exams, right? You're going to work a question, and then something like this is going to happen. You're going to observe that the rest of values are whole, and boy oh boy, must I have made an error somewhere, and it's going to eat you up inside, you know. But you need to breathe, let it go, and move on, as we shall be doing. So that's the value. X is equal to 7 over 4. All right, next up, given that the determinant of AB is equal to -10, show that x equal 2. So clearly this part 2 is not related to part 1 because they have used a new refreshed value for x. All right, and they're saying, what if our condition is such that the determinant of the product of A and B? So first up, people, we need to do some matrix multiplication, okay? So let's step aside and I will guide you guys a quick recall as to how to multiply. You know, 3 by 3 matrices. It's you're gonna multiply the rows in the first matrix by the columns in the second one. All right, so first up, what I'm going to do is highlight the row by the column that we will be multiplying. I'll show you guys 1 or 2 and then I'll just do the rest off screen, okay? So let's get into it. So to get this first value here, all right, just one value, we're going to have to multiply every single element in this row by every single element in this column. So we're going with 2 by 1 plus, you're going to have x by 2. You know what? Let's just multiply it. Anyway, I'll leave it showing like this for the sake of you guys understanding what's going on. Okay, so we have x by 2 plus -1 multiplied by 2. Now, these 3 individual workings here only gives you, if your answer has to be, obviously, it's going to be an array that has, well, a 3 by 3 array, right? What we worked out on screen there is simply going to give us this value after we add it. All right. So to get the next value, say if you wanted to achieve the value below here, then what you need to think about is, hey, what row and column does that element belong in? Well, it belongs in row 2 and column 1. Therefore, if I wanted to achieve this value here, what I need to do is in my first matrix, I need to highlight my row 2. And in my second matrix, I need to highlight my first column. So you always go in the order of rows by columns. And that's what you pick to multiply. You will multiply 3 by 1 plus 0 by 2 plus 2 by 2. So you keep alternating, not alternating rather, you have to make sure you line up what values you're multiplying. You'll multiply the first value by the first, you multiply your second by your second, and your third by your third. So this requires a lot of practice to get the hang of it, right? And I think I'll do the last one below here for you guys. If we wanted to achieve this element over here that belongs in row 3, column 1. Therefore, we would need to highlight row 3 and column 1. And we'd go ahead and multiply 2 by 1 plus 1 by 2 plus 0 by 2. And that should give us the first 3 elements of our column 1. Alright guys, so I'm going to go off screen and just finish this up, and of course you guys can double check and make sure you did it correctly as well. Let's clean up these rows. Actually, I think I'll go off screen because I hear a lot of barking in the background. Must be the neighbor's dogs again. Okay guys, that was a lot of work. Took me a whole, about 2 minutes I think. Yeah. It wasn't like difficult, but just the constant multiplying and making sure you're not making any mistakes. So hopefully I did not make any mistakes. Yeah. So all that work was just simply to find a product matrix AB. Now they're saying given that determinant of AB. So what we need to do is just go to our little side here. Actually, I think I'll scroll down. All right. Scroll down. And let's find the determinant of this matrix, shall we? So very easily, the determinant of this matrix, they're saying is equal to 10. Oh no, -10, sorry. Which is equal to -10. It's given by our, it will be given by, first of all, 2x, determinant of 8, 19, 7, 14, then minus 3x plus 5, determinant of that's 7, 19, 4, 14, and then let's just make this a little bit smaller. Alright, shift to the side here, and plus 4x plus 8, let's put that in brackets, by that's 7, 8, 4, 7. Ugh, thank God it's a proof. Alright, I think they said x has a value of 2, so if we get that, yay, we did it correctly. So on the left, negative 10. On the right, we have 2x by the determinants of these. I'm going to pause here and just use my calculator to work out all of these values. Okay, and in doing that question, I realized in working it out, I had an error over here. This is supposed to be 1. Alright, so just showing you guys small errors like that do happen, and when it's a proof you can tell you made an error. So over here, this value needs to change. Alright, so let's just fix that. This will be 2 2s are 4 plus 3x, so we will have 3x here. We would have gotten 4 plus negative 1, that's 4 minus 1, that's 3. So this is actually supposed to be 3x plus 3. And I believe, of course, that would produce changes. We would have 3x plus 3 following through our entire question. So over here, we'd have that change. We'll have that change here. Right, so plus 3. Over here, we'll have the 3. And from this line here is where I would need to make changes. Alright, guys, so I'm going to pause and get back to you guys in 1 second. Okay, guys, so once you make that little correction there, there, and there, that fixes everything, and your answer works out to be 2. Now take note that this question was a proof, and as usual, y'all know how I roll, I always forget to write. So given that show, right, so it's a proof, so we start off writing those important words, proof, and you write down what you're supposed to prove, and when you have reached your final answer, you write your little QED box. Alright, guys, so that's it there. Now I want to say something. These questions, you see, these types of questions here that tend to be lengthy and draining in terms of use of calculator and algebra and having to remain fixated and focused, they can tend to mess you up sometimes because, I mean, the intensity of the question is not there. The complexity is not there, but the focus is there. So there's room for errors very easily. And I can safely tell you guys on my end, when I was on pause and working it out, I probably made mistakes at least 3 different times. Okay, I multiplied wrong, I added wrong, even with the calculator. I missed adding a term, you know, I carried across terms wrong, you know, little things like that. So I love proofs because it definitely it's like you have the answer to work towards. You can see where you're making your errors and stuff like that. So yeah, so stay tuned. We're going to be doing I think there's one more part to this past paper, and then we'll be moving on to 2018. Okay, so part 3 was actually really easy. They just simply stated hence obtain A inverse. And the reason that hence is coming forth is because in order to find the inverse, in terms of numbers only, you would want that value of x. So hence, we are simply going to write that hence our matrix A is now going to be equal to, let's see what we had above. Our matrix A was given by 2, 3, 2. So let's write that down. We had this being 2, 3, 2, and then x. This is where the hence part comes in. We're going to use x as 2 here. And then continuing 0, 1. Alright, so we'll have 0, 1 here. And the last 3 numbers, 2, 3, 1, 2, 3, 2, 2, 0, 1, 2, 3, 2, 2, 0, 1, and then minus 1, 2, 0. Alright, so minus 1, 2, and 0. So there's our hence part. Now straight up, we're gonna find the inverse of a 3 by 3 matrix. You guys can use the cofactor method, which is the one I am going to use right now. And just in case you forgot, when you're finding the inverse of a 3 by 3 matrix, it's given by this formula, 1 over our determinant, and by the adjoint of A, right? Take note that the adjoint of A is simply the matrix of the cofactors transposed. All right. So first thing we need to do would be to find those cofactors. So some students like to write them out individually. You can, I mean, you could go ahead and work out the determinant of A first. That will give you 3 of your cofactors if you think about it. Or you can just go ahead and write them out individually as follows, right? You can have A11, A12, A13, and you can list them out as follows. Take note that the signs will be changing. So for example, your first value will be positive, then negative, then positive, and you will have your first value there, right, by your remnant. Let's see the remnant here. It will be 0, 2, 1, 0, right? And then here we will have A12. So you'll have 2 here. And what's left? You have 3, 2, 2, 0. So I'm simply blocking all the rows and columns that the number I have put a dot on belongs to. This one, we will have -1. And the remnants would be 3, 0, 2, 1. And you continue this pattern for all of them. So I'm going to go off screen and just continue this pattern for the rest and get my values. All right, I'm working this one on screen. We will get 0, that's -2. This one will give us -2 by 0, -4. And this one will give us -1 by 3. All right, so we have some values there, -4, 8, and -3. Hopefully we didn't make any mistakes there. You all can be sure to leave me a comment down below if I did, but the method is on point. Okay, guys, so stay tuned as I do the rest of the cofactors. Okay, so it took me 3 minutes and a couple of seconds to get all of these cofactors listed down here. And of course, that cofactor method, you can check my YouTube video as to how to find cofactors. We're not going to get into that in the question tutorial, people. Okay, guys, so after getting all of your cofactors, you want to list them out accordingly. So if you found the value of A sub 11, it goes in that particular location. First row, first column. If you found A sub 2, 3, it would go in row 2, column 3. Remember, always it's RC, row by column. Now, of course, the formula for finding the inverse when it comes to a 3 by 3 matrix is given as follows. Up here, I wrote it down right here. Let me change that color so I can highlight it better. Let me do that in green. Okay, so up here, the A inverse is given by 1 over the determinant of A, which we found to be 1. And after finding the cofactors, you can easily find your determinant. So I usually like to find my determinant after, you can find it before, I mean, it's the same thing, but you know. Right, so we simply make our statement that therefore, our A inverse is given by this formula, 1 over your determinant, which we found our determinant to be 1. And the adjoint, remember, is the transpose of your matrix of cofactors. So 1 over 1 is simply 1. We're going to let that go as is and simply write down the transpose. Transpose means that your rows become columns. So this first row here is going to be rewritten vertically instead of horizontally. 8 and -3. No sign change here. -3, 0, 4, and lastly 8, -7, and 0, and that's it. That's your answer. Usually you would have had 1 over some value here, but because our determinant worked out to be 1, we do not have any number written in front there. And that's your final answer, guys. Be sure to work it out on your own and give me a comment below if I made any errors. I'd love to know, because I worked this question out without any answers nearby. I just decided to wing it, okay? So that's the end of 2019. If you knew your basics in matrices, you would have gotten full marks in this question. Woot! All right, stay tuned. 2018 is coming up next. Okay, 2018, woot! I'm getting excited, guys. Really, I am. Because, I mean, yeah, matrices, this is where you get your marks, right? I consider matrices to be a very mechanical topic, meaning that once you know the method, it's just pretty much to eliminate as many calculated errors and human errors as possible. But there's not too much thinking required. So if you're looking for a topic to get easy marks, matrices in module 3, matrices would definitely be the way to go. All right, guys, so we're not going to do too many past papers in this topic. Like I said, I have 11 teaching videos up on this, and they're going to repeat themselves. They're either going to ask you to find the inverse, they're going to ask you to find some random value within the array of numbers, they're going to ask you to prove that the product of something, or they're going to simply ask you to solve a system of equations, okay? So I think once we have encountered sufficient types of these, we will stop there. Okay, so I'm not sure we're going down to 2015 this time. Let's see how it goes. All right. So in this question, two matrices are given as follows: A and B, 3 by 3. By finding AB, oh man, okay, we have to go multiply again. But please recall my method from 2019, and what I'm going to do is I'm going to paste the solution on screen, and you guys can work towards getting that by reviewing my answer from 2019 in terms of method, how to multiply, right? And if you get any mistakes, you can leave a comment down below and I can explain where you went wrong. Okay, so here goes. We're going to find the product of matrix A and B and then deduce that the inverse is given as follows. So this is a type of a proof. I'm going to simply write required to deduce, all right, for need of statement that A inverse is going to be equal to 1 over 88 by the matrix B. So let's get into it, shall we? Now, something very, very interesting has happened. I've noticed that after I found the product of matrix A and B, I got, well, you should be able to recall. All right, guys, the identity matrix and what it looks like, right? An identity matrix, you have your diagonals, your leading diagonal from left to right being 1s, and then the remnant of your elements in your array being 0s. Now, considering that fact, what I can safely say from observance is that this can be rewritten as 88. If I were to factor out 88, I would get my identity matrix being 1, 1, 1, 0, 0, 0, 0, 0, 0, right? And of course, instead of writing all of that, jalala, I can just simply write 88i. All right, so some interesting things are happening here, right? So we have found that AB is giving us 88 by the identity matrix. Now from here our answer is in the bag. You can see it already, but there are some essential steps to write out. So we have to prove that A inverse is equal to 1 over 88B, right? And we have arrived at this situation here. Now if you want to perform some algebra, remember you can carry across that 88 on your left hand side such that you have A, B all on 88, right, is equal to I. So that's our identity matrix here. But the thing is, they want us essentially to show that A inverse is equal to this thingy here. Now, how do we achieve the identity matrix? right? That's the question you have to ask yourself. So, for example, the basics. If you have a matrix A and you were to multiply it by its inverse, you would get the identity matrix, right? Similarly, if you have a matrix B, you multiply it by its inverse, you should get the identity matrix. So over here, you are seeing that we have the identity matrix, and on the left-hand side, you have the product of two types of matrices, right? But going back to what they want us to show, you are seeing that A inverse is equal to something. So essentially what you're trying to look for is a value for A inverse. You see, we have A already, right? So what we need is A inverse, and we're going to utilize this information here that A by its inverse gives you the identity matrix. Using that knowledge, we're simply going to split. Look at this, look how simple it is. We're going to take that A, write it back here, and we're kind of going to separate that B on 88. See how we're doing it? In a smart way, such that this is A, right? In our square brackets, really is A inverse, right? A by A inverse is going to give us our identity matrix. And if we were to take that over 88 here and simply rewrite it as 1 over 88, guess what? What do you guys see? That's correct. That is exactly what the question has asked us to prove, that A inverse is equal to 1 over 88B, right? So seeing it right here, that means that these two are equal to each other. So using that identity information, being able to equate, you see in maths, equating is the key. It's essential in attaining a lot of answers. Some students would have gone on to probably use B to find A inverse somehow. You know, they may have attempted to find A inverse and then multiply B by 1 over 88 and show that the both sides were equal, you know. But from here, the answer was very straightforward. It was staring you in the face. You just had to make some key rearrangements using basic knowledge. Okay, guys, so look out for stuff like that popping up, and there you have it. So we're required to reduce that, and we have shown it. So that's the end of your solution for this type of question. And hey guys, I remembered to write my QED box. Woot! Let's stay tuned. I think we have one more part to 2018, and then we'll be moving on to 2017. So hold on. Okay, last part to our question. It's a hence. I don't know, things must be good because I'm remembering to start my questions with hence and so on. So yeah. So hence, since previously we found A inverse to be equal to 1 over 88b, we're going to use this information and solve this system of equations. Now, also recall when you're solving system of equations like this, you know, you have some form of A multiplied by a solution here is equal to an array of numbers. Then let's just call this, usually they have ax is equal to b and so on like that, right? Usually this implies that you know, x is simply equal to a inverse by whatever that b is. So using this basics of solving system of equations, we can simply say that x, which is represented by our x, y, and z, would just be equal to our matrix A inverse, right? Multiply by whatever B is. Now in this case, we won't use B to represent that because we do have a matrix B present. So let's call that C. And our C in this question is simply 7, 11, and negative 6. And by extension, since we found A inverse to be equal to 1 over 88B, we will just simply replace that with what we know. From above, the matrix B was, let's see, matrix B is 18, 12, negative 1, and negative 8, 24, 20. And then finally, we have negative 6, negative 4, 15. All right, guys, and don't forget to multiply by your 7, 11, negative 16. So for me, it's just a simple multiplication that has to take place. So I'll just go ahead and paste the solution because I have it already worked out for you guys. So there it is. Let me scroll down here. All right, so scrolling down here. All right, I really wanted to show you guys this statement. I didn't just want to write out the answer like that. So we have that previously, right? This was your matrix A over here, right? By your system is equal to some matrix C, right? And therefore your matrix X is equal to your A inverse by your system, all right? And X is just equal to the product. You go ahead, you take your time, you perform your matrix multiplication from here, and you attain your answers. So just remember, when you're multiplying matrices, it's row by column. If I were to do this for you guys, I would have retained my 1 over 88, and then I would have produced my answer as follows, 18 by 7 plus 12 by 11 plus negative 1 by negative 6, and so on. And then you continue that for the other two parts there. Okay, guys, so if you got varying answers, be sure to leave me a message down below. But this question, these are the actual solutions I have from CAPE. So stay tuned. We are going to move on to 2017 coming up next. Okay, and look at this question. It's sort of a repeat. If you look at it, the product of these matrices you are required to show. So it's a Pro 4. I'm just remembering matrices is totally clearing my mind, guys. All right, so you're required to prove that the product of these two matrices is equal to some form of 20 multiplied by your identity matrix, right? So I'm going to pull on screen the solution for the product of these matrices for you guys now. Okay, and there it is. There is your nice, neat little solution there, after you have spent about 3 minutes, I'd say 2 to 3 minutes to carefully and correctly multiply these two matrices. You should arrive at 20, 0, 0, etc. And you should be able to identify that, hey, if I factor out 20, it's going to be 20i. Right, so from here, you can stop and end your QED box here. But from the previous past paper question, you should be able now to see that what's in brackets is really A by A inverse. So if the question had asked you, this is just an extra here, okay? If the question had asked you to prove that A inverse is equal to 1 on 20b, now you know how to do it, okay, guys? So every time you do a past paper, you're going to learn something new. And you're also going to see that things repeat themselves, and once they do and you are exposed to that type of question, there's additional knowledge that you gain. All right, so always be willing to keep your minds open to new types of solutions that you may encounter as you practice, right? Okay, so stay tuned. We have more parts to this question. This one is not very long. Okay, guys, so our next part right here, it was a hence question. This is the reason why I kind of left part 1 there, so you guys can see the follow through. Right, so part 1, recall, we were required to show that AB is equal to 20i. That's this part here. And I was telling you guys, even though we needed to stop over here, that we could have also gathered this information that A inverse would be what's in this bracket here, right? And it's just straightforward that, and kind of obvious that in part 2 they actually asked hence, right? So your answer for part 2 would have begun from here. All right, so part 2 answer would be hence. You would have taken your part 1 answer. All right, so this was your answer for part 1. You would have taken your answer from part 1 and said, hey, I know that a matrix by its inverse produces the identity. So therefore, what's in my bracket actually is A inverse, and you simply write out your full matrix B to show them, right? And hence deduce the inverse of the matrix, deduce the inverse A inverse of the matrix A. It's given by this. If you wanted to bring in that 20, you can, but it looks nice and neat as it is. Personally, I do not like fractions like these in a matrix unless it cleans it up perfectly to whole numbers. That's the only way I'll bring in a fraction that's written, that determinant outside. Okay, and that's it there. That's the part 2 answer. Let's see what they have for part 3. Okay, so finishing up our 2017, is it? Yeah, 2017 here. We have hence, or otherwise, of course, you all know we're going to use the hence because the hence is just the shortest way to go. All right, so hence, they want us to solve the system of linear equations. So first of all, what I'm going to do is just rewrite my system in matrix form. All right, so we have the coefficients of each of those variables being pulled out here. So coefficients of z in that column, being very careful. You would have, what are my variables present? X, y, and z. There are some students that have signs in front of their variables. I'm not sure why, but please do not make that mistake. And on the right hand side, we have 1, 5, and 25. Now we can see that this matrix over here, right, is the same as the matrix we had previously in our given question. All right, that matrix, I think it was A. Yeah, that was the matrix A, right? So pretty much to solve this system of equations, if we call this our A by our X is equal to our C, because we already have a matrix B in this question, our solution is just going to be given by A inverse by C. You want to always, always, always multiply your A inverse first, right? That first by your C, otherwise matrix multiplication will not be allowed. Remember, matrices need to be a particular order in order that multiplication can occur. So always make sure you write this first, okay? All right, so moving along, we will eventually get that our system X, Y, and Z is simply going to produce, remember, this is where the hence part comes in. We had A inverse being equal to 1 on 20, right? So that was 1 on 20 by B, I believe. And our C is 1, 5, and 25. Okay, so just write out your matrix B, your 30, negative 12, etc., and you will get your answer. Let me just pull that in for you guys. So those of you who are working along with me, you know, you can verify that your answer is correct with the solutions I am going to place on screen here. All right, so here they are. All right, so just bring them in here for you guys to see. All right, on screen, right, we have 1 on 20, our matrix B. Let me see if I can make this larger so it can line up better. All right, yeah, that's good. All right, so simply matrix B, just simply replace it with that. And if you couldn't remember how to multiply, guys, don't forget how to multiply matrices, okay? Keeping that 1 on 20 over there, you're multiplying 30 by 1, right? Keep it in brackets, plus negative 12 by 5. Keep it in brackets, plus 2 by 25. That's going to give you your value for x there, right? 30 minus 60, that's minus 30 plus 50. All right, 50 minus 30 gives us our 20 up here, right? And 20 divided by 20 gives us our 1. So keep going, work out your other 2 rows of values using that method. Of course, if you have severe trouble multiplying matrices and so on, be sure to review my videos where I have full tutorials, full worksheets, full solutions. I actually teach the topic, so you can look at those videos and you will see how to matrix multiply and so on. Okay, guys, so that's the end of 2017. And I'm sitting here wondering if to continue. So let me just check out how long 2016 is. If it is very lengthy, I think we'll stop here. If it's not, we'll give it a go. So I decided to give it a go just so you guys understand why I am planning to end this video on 2016. It's becoming redundant, right? So my aim is to expose you to as many different types of wording of questions, you know, different complexity levels. But if it's repetitive, if you've seen one, you can keep practicing that type of question just by changing around the numbers, okay? In this question 2016, they gave us a matrix and they simply asked us to find the determinant. We have done that 2 times in 2019, 2018, I think also 2017. So just go over how to find the determinant of a 3 by 3 matrix. Okay, the answer, if you want solutions on screen, I am bringing it in right here. All right, remember you have your alternating signs. Key things to remember. You want to make sure when you're finding the determinant, you start with a positive sign, then you keep alternating. Then, of course, when you pick your first number, you have to eliminate the rows and columns it belongs to and create a sort of determinant of the remnant of those elements there, right? So the reason the first number worked out to be equal to 0 was that you're going to have 2 being multiplied by the product of 4 by 0 is 0 minus 6 by 3 is 18. All right, so I think they have this question wrong actually. Okay, so yeah, question like this, pretty basic. You know, you start off setting up your answer with your plus, your first number there. You eliminate rows and columns that belongs to. You write down your remnants. Minus 1, you have 0, 3, minus 1, 0, plus again, minus 1. Remember, these numbers are coming from here, here, and here, okay? And then your remnants, when you eliminate that row and column, you get 0, 4, negative 1, 6. Okay, what do I mean? Negative 1 belongs to this row and this column, so my remnants are as follows. Then you go ahead. You work out your determinant, 4 by 0 minus 18 minus 1 by 0 by 0 minus minus 3. That's plus 3 minus 1 by 0 by 6. That's 0 minus minus 4. All right, so sometimes the signs can get a bit tricky. You gotta just take your time. All right, guys, and once you're done, you just plug that into your calculator. Let me see how fast I can do this one because I have no solutions. Actually, I have a solution, but interestingly enough, the solution I have has an error in it. So I'm just working this out from scratch here live. All right, and I have gotten negative 43. All right, for the determinant of A here. Why did I write this? It's just the determinant of A, okay? All right, so yeah, that's pretty much it there. And I mean, we can continue doing this all the way down till the end. The next part pretty much is just to find the inverse, and I'll just show you a shortcut on screen. Let me just save the solution. I do have this solution, a correct solution. I'll share with you guys who are interested in working this 2016 question all the way out to the end. All right, so if you want to know the method you used, please be sure to just simply review. I think it was 2018 we did this exact type of question. If you want to find, so let me put the part 2 to this question. It was to find simply the inverse of the matrix, right? And remember, that's given by your formula 1 on your determinant by your adjoint of your matrix, right? And your adjoint of your matrix, you have to recall that you have to find transpose of your cofactors and stuff like that. So I'll give you guys a little short peek into the solutions for this part 2. All right, so it looks like this. All right, that's 1 over your determinant there, and the cofactors look as follows. So take your time, work out your cofactors, remember to transpose them, and that's your answer on screen. Okay guys, so pretty much, and that was the whole of 2016. Yeah, so you can see so far all of the questions that matrices have come under have been very straightforward, very simple. Usually only 3x3 matrices you want to get into. So you find the inverse, you understand what a singular matrix is, you understand what it means when a determinant of a matrix is 0. Of course, we have not encountered any with Cramer's rule. Well, I actually didn't use Cramer's rule. Cramer's rule is also a nice one. I have a full video on using Cramer's rule. It's just that I really like to use the cofactor method when finding the inverse. But those of you who are solving, when you have a system of equations you want to solve, that's when I do use Cramer's rule if it's not like a hence. But it's a formula you have to memorize. So if you're not good with formulas, you might prefer the cofactor method, right? It's shorter and simpler. If you make one mistake in Cramer's rule, it can all go wrong for you. All right, guys, so take your time. Review this topic in detail. It is coming. They listed it as one that's coming. They know it's a simple topic, people. So if you want to gain your marks, do not just fly by this topic and think that it's so easy. Knowing that it's going to be one on the paper, they are going to try to bring a trick into it. Utilize all the past papers that we have done, especially that little one with where you get 1/88 by B, stuff like that. Look out for it coming. Make sure you have your knowledge of how to find cofactors, you understand your formulas that you need to use, and practice matrix multiplication thoroughly. These are the parts that you need to make your marks in. These are sure marks. Just can be easily lost by calculated errors. So take your time, guys. I wish you all the best. I think it's I want to do a short little video on this thingy here where you have roots of equations. I forgot what was the name, right? Roots of equations. There are not many past papers that have them, but it's when you have a root given as alpha, beta, gamma, etc., and they want you to find the values of 1 on alpha plus 1 on beta plus 1 on gamma, etc. Right? So I'll be contemplating doing a very short video. It'll be short because I don't think I'll find many past paper questions that have these types in it. Probably 2, who knows? It'll be quite a short video, probably like 20 minutes or something like that. So that's the next video to look out for. And then lastly, to make sure I cover every single topic that they said is coming, I need to do a video on this counting. Alright guys, so if you don't know me, I mean, believe it or not, maths teachers have their preferred favorite topics, right? And when it comes to statistics, alright, I wouldn't say statistics is my least favorite topic, but components of statistics are my least favorite. I do not like permutations and combinations. Yes, yes, yes. Now you know. Now you know my secret. Okay, in mathematics, I love pure. I love everything with algebra. I love everything that has iterations and proofs and, formulas and everything just like that's abstract. When it comes to statistics is very easy. Tongue twister there. Statistics is very easy. Yes, it's a nice topic. Woohoo, most students love it, and kudos for that. It's interesting, it's real life. You think on the spot about situations that are real. But I don't know why I do not like permutations and combinations. Tree diagrams, yay, basic mode, million and mean, yay. When it comes to plumes and comes, I don't know. So making a video on counting will be like, wow. When you see that video come, it's because I literally procrastinated that, okay guys, I need to get down and do this video. So I'm doing everything under the sun to not do it right now. But I know I need to, okay guys? So I am officially calling it the end of all the videos I'll be making anytime soon, minus that roots of equations to come and permutations. Okay guys, so I hope this is enough study material. I have one request from a student asking to see some multiple choice. So after I have produced all my videos and so on, I think I may just start doing some multiple choice past papers, right? Probably 1 year at a time and see how that goes. So it was good to be with you guys. I wish you all the best and keep sharing my videos. And I am so happy that you guys are learning something new every time you view them. Okay, guys, take care and all the best. Bye.